All right, today we're going to talk about lesson 722, which is focusing in on the special quadrilateral of a rhombus. Okay, and if you remember, a rhombus is actually a special parallelogram that has four congruent sides. Okay, so a rhombus has all the properties of a parallelogram, plus we know that all four sides are congruent. There are some other special properties besides four congruent sides. We know since it's a parallelogram that opposite sides will be parallel, opposite angles are congruent, consecutive angles, so two angles in a row will be supplementary, and each diagonal cuts the parallelogram or the rhombus into two congruent triangles. Okay, but even more special in a rhombus, again, we know all four sides are congruent. We know that the diagonals actually form four congruent triangles, and the diagonals are perpendicular to each other. So a trick for drawing a really good looking rhombus is to make a plus sign first. I'm going to make one of the diagonals longer, so I'm just going to count 4 lines on my paper, just 4 spaces. And then I'm going to go left to right. I'm just eyeballing it about the same. And then I'm going to go down 4 more spaces. And those are actually the diagonals of my rhombus. So if I connect the edges, what I have are 4 congruent triangles, and including those 4 sides are the same. That is a rhombus, okay? So again, the keys to a rhombus: 4 congruent sides, diagonals are perpendicular to each other, and those 2 diagonals actually create 4 congruent right triangles. So diagonals create 4 congruent right triangles. Now, at some point in time, we can't just assume that this is true because Mrs. Miller is telling me it's true. We have to prove some of this stuff. We're gonna go with, oh, you know what else? Diagonals bisect each other. Diagonals bisect each other. Okay, and really what that's saying is that these two are congruent and those two are congruent. Okay, remember, bisect, bi means two, sect means to cut, so we're cutting into 2 equal pieces. The diagonals cut each other into 2 equal pieces. And that's something that's special to a rhombus that's not true. It is true in all parallelograms, okay? We're gonna prove this one today. So we're gonna make a flow chart, and we're gonna prove that if a shape is a rhombus, then the diagonals bisect each other. Okay, so we always want to start our proof with what's given. Okay, well, the given part is the if part, if a shape is a rhombus. So I'm going to say in my very first bubble, that PQRS is a rhombus. PQRS is a rhombus. And that was given information, okay? Now, again, this is where sometimes it gets tricky. What we're gonna say is, because we know it's a rhombus, we know that opposite sides are actually parallel, okay? And I'm just gonna pick a set of sides. I'm not gonna use both for this. Reminder that you're not gonna have to come up with this type of proof on your own, but you may have to drag and drop and fill in the blanks correctly. So we'll get lots of practice over this week and next week. And again, today the point is for you to take really good notes and then be able to answer some questions a little bit later. So I'm going to say PQ is parallel to SR. Okay, and the reason is rhombi, which is the plural of rhombus, have opposite sides parallel, okay? In a rhombus, opposite sides are parallel. Now, remember, what we're really trying to prove is that these two pieces are equal and that those two pieces are equal. I'm going to add in a letter in the middle just so that we can talk about each piece separately, okay? So we know that those are parallel. Hopefully you're getting the concept, and we practice this enough, that when lines are parallel and there's a transversal, that's going to lead us to congruent angles. Okay, so because these two lines are parallel, and I'm using the Z, I can say that angle PQS is congruent to angle RSQ. Remember, I can name angles forwards or backwards. Okay, forwards or backwards, and it's still the same. If lines are parallel, then alternate interior angles, are congruent. Okay, notice I'm using some shortcuts. If lines are parallel, then alternate interior angles are congruent. I can also use the backwards Z, to say that those angles are congruent. Okay, so I use the forward Z here, I'm going to use the backward Z here. Okay, QPR, angle QPR, is congruent to SRP, angle SRP. And again, my reason is if I have parallel lines, then alternate interior angles are congruent. Okay, and I did shorten that up a little bit, but I did write it all the way out in that side. Okay. The other thing that I want to say is that not because of the arrows, but because it's a rhombus, that side PQ is congruent to side SR, okay? So PQ is congruent to SR. You might think, where are we going with this, okay? But if we show that those two sides are congruent because it's a rhombus, okay? If it's a rhombus, then it has 4 congruent sides, okay? And we knew it was a rhombus, that was given. So, and I could connect these, but I don't want to add too many arrows. What we've just proven is that those two triangles up top and on the bottom, the two small triangles, are congruent. So triangle PQT is congruent to triangles PQT. I'm following the pink Z, so RST, or you could think PQT is blue, pink, nothing. RST, blue, pink, nothing. Okay, I've proven that those two triangles are congruent by angle, side angle congruence. Okay, and the reason that is helpful is now that I know that the sides are congruent, that the triangles are congruent, I can say that their corresponding parts are congruent. So remember, the goal was to say that these parts were congruent. PT, okay, is congruent to TR. Because once we prove that triangles are congruent, we can say corresponding parts of congruent triangles are congruent. Okay, the shortcut for that is CPCTC. And you can use that shortcut when you have these words memorized. So make sure you know it means corresponding parts of congruent triangles are congruent. Okay, and again, we're also showing that these two, ST and TQ, are congruent. Same reason, corresponding parts of congruent triangles are congruent. Once we've proven that two triangles are congruent, we can say that their corresponding parts are also congruent. When we say that these corresponding parts are congruent, we are saying that the diagonals are bisecting each other, okay? So I know that that's a lot. I know that that's kind of a complicated proof, but again, write down the notes. Make sure you have really good notes so that you can understand how to answer certain questions. Start getting the idea that we're using given information to prove something, and often we want to prove two triangles congruent so that we can prove that their corresponding parts are also congruent.